Welcome to everyone. Today class will discuss on topic matrices. So we are discussing this topic matrices here. It is because this matrices helps us to explain the change in configuration of the molecules mathematically. Means this matrices helps us to explain the change in configurations of the molecule mathematically. That's why we are studying that matrices here, and we can discuss more. And this matrices, what that we are using the symmetry operations in group theory. So these symmetry operations, the symmetry operations are represented as linear transformations with respect to Cartesian coordination systems, Cartesian coordinate systems, then the matrices are produced. So whenever we are using the symmetry representation, whenever with the symmetry representation are represented as linear transformations with respect to Cartesian coordinate system, then these matrices are produced. Okay, so what are these matrices? These matrices are like these matrices are a rectangular array. They are a rectangular array which combines the which is the arrangement of the molecules and arrangement of the numbers, or arrangement of combinations of the arrangement of combinations of numbers which can be added with other matrices following certain rules. So let's discuss about of that. Let's say that we have that identity operations. So let's take that here. If we have that coordinate systems, and let's say this is y-axis, this is x-axis, and this is z-axis, and if we have the points here, and let's say this is a vectors O A and this is R vector. So in this case this has coordinate, let's say x1, y1, z1, and if I apply that identity operations to this vector R, or to this OA, to this coordinates. So if we apply identity operations to these coordinates, vector OA or coordinates x1 y1 z1, then what will happen, that it will give some operations, that is represented operations. So the mathematically we can represent, so the mathematically if I represent, let's say mathematically how can I represent that, let's say E operations, it will give some operations with, I will write something with coordinates, let's write about something after that we will do with coordinates x2 y2, or I will write with coordinates x2 y2 and z2, which gives new coordinates, which give new coordinates x2 y2 and z2, which is same as initial one. What means it, that let's say we have that x2 y2 and z2, and we have that symmetry. This is the that is, we can say that matrices, and we apply that symmetry operations E identity, then what it will give rise, that previously we have x1 plus 0 y1 plus 0 z1, and this is, let's say 0 x1 plus y1 plus 0 z1, and 0 x1 plus 0 y1 plus z1. So this is the operations it will give rise, and this is equal to what, this is equal to, we can say that here I can say 1, this is 0 multiplied by 0 is 0, and this is also 0, and this is 0, and this is 1, this is 0, and this is 0, this is 0, and this is 1, and this give rise to x1 y1 and z1, means same that operations will return. So this is the operations of, after we operating that the coordinates, we get the same. So this matrices is identity matrices, or also called unity matrices, where in this matrices what there, that this is that only corners have coordinate value of 1, and others value is 0. Okay, and these are what, these identity matrices, this is of the order of 3:3, and it is the order of 3:3. So these identity matrices we will use in the matrices for operating the variety of operations, like we have that C2 operations, Cn operations, we have Sn operations, we have I operations, we have plane of symmetry operations, sigma operations. So we use these identity matrices to check that, to examine that what is the change in the configurations of the molecules. So let's discuss one by one. So in this identity operations, what we see that in identity when we apply E, then we get that what we get that this values we get this values. So this value is this diagonal value on all 0. So another thing, the very important things why you are studying actually that matrices, that this the diagonal. So this we'll learn one, that is characters of matrices. So it is represented as character matrices. It is represented. We'll talk about the character matrices. It is represented as these symbols, and it is also other name. One is character, we say another. It is also known as trace. And but actually that characteristics, it is the addition of diagonal values, diagonal, or you can say main diagonal values. So here that characters means additions of diagonal values. So here the character I can represent like this, and this is for E. We are seeing identity matrix, so I will write here E. It is the additions of this diagonal value, so I can do here. So I will erase this one, it's fine. So this is the value E, and this additions of all diagonal value means 1 plus 1 plus 1, that is equal to 3. So characters of this identity operations H3. Okay. So why actually you are studying the matrices, that we will give rise to one identity matrices, and this identity matrices is used to examine the change in the configuration of the molecules. So we will discuss, and from here we will what that calculate the characters. Characters means that diagonal addition of the diagonal values, that gives rise to here 3. So next we will discuss. Let's look. If I look about of the plane of symmetry operations, so that is plane of symmetry operations, what is that? Is reflections, that is sigma we are applying. So in this case, let's look. If I talk about of this, so if we have like any axis x1 y1 z1, this is the matrices, or I will write let's say x1 y1 and z1, this matrices. And if I apply that sigma, that is plane of symmetry operations or reflections, if I apply, then what this matrices, let's say this is x, this is y, and this is z, and these planes, suppose I apply that y and z directions. So this, if I y z, then what, that y and z remain unchanged, and this will change. This will become minus x1 and y1 and z1. So if I represent it in mathematically, because I want to know the character value, that character value I will use to check that properties of the molecule. So actually I need the character. This one if I represent mathematically, then how I represent that x1. So this is minus, so I write minus x1 plus 0 y1 plus 0 z1, and this is 0 y1, and this is y1, and this is 0 z1, and this is x1, and this is 0 x1, plus this is 0 y1, plus this is z1. So we have studied the matrices how I am writing. So this will multiplied by this. I am doing that. Let's see. So this will become what? That is here 1 is there, that is -1. This is 0, this is 0, and this is 0, this is 1, this is 0, this is 0, this is 0, this is 1, and this has will give x1, y1, and z1. So if we multiply by x1 to this and this and this, we will get the this values. Okay, so now what we get, that we are after applying that plane of symmetries, plane of symmetry operations to this identity operation, this identity let's say unity matrices. What you get, that this unit matrices, this matrices we get. So we apply that unity matrices to this operations. After that, the unity matrices change to these forms. Now here we use the trace, that is characters. So what is the characters of this? So characters of sigma, that is what, that summations of the diagonal values, summations of the diagonal values. So what is the value? -1 plus 1 plus 1, that give rise to plus 1. So that characters of sigma value is 1 value. So to get this characters value, actually we are using that unity matrices, and this characters value we will use to uh, understand the properties of the molecules, that we'll discuss after some times. Okay, so like this, for plane of symmetry operations, the characters value we get, that is 1. Okay, similarly we will get another matrices. So another symmetry operations, let's say center of symmetries. Let's discuss about our center of symmetry. I use, and in this case let's say I, and let's say x1, y1, and z1. So if I use it, then this will inverted all the coordinates that we already discussed, that will become -x1, y1, and -z1. So this is actually, how can you represent that? -x1 plus 0 y1 plus 0 z1, and this is 0 x1 plus this is -y1 plus 0 z1, and this is x1 plus 0 y1 plus z1, and this one we can write this one as this is here -1 0 0, so this is also minus z1. Okay, this is 0 -1 0 0 0 -1 0 0 -1, and it will give rise to x1, y1, and z1, which we applied. Okay, so these matrices that we can calculate the characters of I, then we add the diagonals elements. So this is -1 -1 -1, that give rise equal to -3. Okay, similarly if we applied for center of symmetries, we have applied, and similarly we can apply it for axis of symmetries. So let's apply for axis of symmetry operations. Then what you say that extra symmetry operations, any let's say C2y I applied, so x1 y1 z1 I apply to this, then what will give, so this is C2y, so coordinate system is like this is x, this is y, and this is z. So if I apply C2y, then x and z change, y will remain as it is, so minus x1, and y will remain as it is, and minus z1. So this one we can write as minus x1 plus 0 y1 plus 0 z1, and this is 0 x1 plus y1 plus 0 z1, this is 0 x1, and this is plus 0 y1 and minus z1. Okay. So this here if we get, what we get, that this is minus 1 0 0 0 1 0 0 0 minus 1, and here we get x1 y1 z1. So here that this unit matrix we will calculate the trace or characters, that is trace of C2 is how much, that is minus 1. Similarly this is C2y, similarly we can, this is also sigma C2x equal to, sorry, character of C2y equal to minus 1. We can check it, the same value will get. Similarly for here I apply I for all this case we will get minus 3. Similarly for here sigma we look for yz. Similarly if we look character of yz to characters of xz or characters of xy, any value we will get always 1. Okay, so now the thing is that for C2y the character is minus 1, but for the case of, but for the C3 C4, sorry, C4 and dot others like C5 C6, that will be not equal to minus 1, means that in this way we can calculate. For that we have to use the formula, that is any Cn axis this is valid, that is here the cos theta sin theta 0, and here minus sin theta cos theta 0 0 0 1. So this is correct for all the Cn axis, and n can be any value. Okay, so for this, the character will be the diagonals. This is the characters. So characters for any Cn axis will be cos theta plus cos theta plus 1, that is 2 cos theta plus 1. This is the characters for any diagonals, sorry, any Cn axis. Let's say our Cn axis is, let's say n equal to just a minute, let's say n equal to 2. On that case this is C2. So here if we apply this formula, then what we say, that that is 2 cos theta plus 1. So if n equal to 2, then theta is 180 degree, because this is C2 means 180 degree we are operating, right? So this value will give 2 cos theta is 180 degree plus 1, and we know that 2 cos 180 degree is minus 1, and this is plus 1, that is going to give minus 2 plus 1, that is going to give minus 1. because we know this values, right? Let's say this is 0, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, and let's say 360 degree. So if I write here sine, this is for sine theta. So 0 degree, sine theta 0 degree each, 0, 30 degree each, half, and 45 degree each, 1 upon root 2, and this is root 3 upon 2, and this is 1, and this is 0, 0. Okay. And for cos theta values, this will be start from here 1, after that root 3 by 2, after that this 1 upon root 2, after that 1 by 1 upon 2, after that this is 0. This is just reverse from 90 degree. Okay. And this is minus 1, and this is 1. So this values we should know that values. So if I say that cos 180 degree, that is minus 1, that's why I do like this. Okay. And if I do, so if I ask that, let's say C3 axis, what is that this value? Then again I write 2 cos theta plus 1. So here theta is 360 upon 3, that is 120 degree. So I will write 2 cos 120 degree plus 1 to 120 degree I don't have, so what I do, 2 cos 90 degree plus 30 degree plus 1. So 2 cos 90 degree, you know that cos 90 degree upon 30 degree, this is equal to sin 30 degree. And similarly, that we know that how this value is come, because this value we can get that a plus b equal to, we know that a square. This we can calculate same way that formula cos a upon a plus b, that is, you know that the formula like we have studied in class 12, that if you use, then we will get the sin 30 degree value. Or we can simply remember that whenever cos 90 30, then this cos 90 will change to sin, and this is 30 degree. Similarly, if you write sin 120 degree, that also you can write cos 30 degree. Why? Because this also again change sin 90 plus 30. So this sin 90 will change to cos, and this 30. Okay. So that I used here 2 cos 90 30 degree. So the cos 90 I change into sin and 30 degree plus 1. Now what we know that this, we should know these things, these coordinate systems. Although this is the 12th class concepts, that here after school to college. So here all are positive, here sin is positive, here tan is positive, here cos is positive. So here we have that cos 180 degree. Okay, the initial value, that is cos 180 degree. So you start cos 180 degree. So here this is just 0, this is 180 degree, this is 270 degree something, and this is 360 degree. So if you move like this, so 120 degree means this is something here, and here that cos 120 degree, that means that is negative. So this value to sin 30 degree, sin 30 degree value is minus 1 upon 2, and this is the negative positive sign will give according to the initial value. This is cos, that's why I use cos 120. After changing we get sin 30, but that will not use for this giving sign. For sign you take the whole value. So whole value is 120, so I will take cos 120, but here the sign is positive but cos is negative, so I will put negative. This sin 30, you may see that sin 30 here it is positive. No, actually you have to take that the initial value, that is cos 120. So that according to that you will take here. According to that sign will come. After that sin 30 degree is 1 upon 2 plus 1, that is going to give minus 1 plus 1, that is going to give 0. So C3 is 0. Okay, so characters of C3 axis is 0. So these are the frequently used terms, so you have to remember, like if I write some characters which are actually frequently used, so characters frequently used, so it is good to remember. So that is C3. So this character is 0, this axis. Similarly C2, this character is minus 1, this C2 minus 1. Write a little bit good. Axis and characters. So for C2, this is minus 1, minus 1, minus 1, okay, and for C3, this is 0, and for sigma plane of symmetry, that is always 1, and that is 1, and for inverse, that is minus 3, and identity, that is 3. So these terms are frequently used, so you have to remember. It is better to remember. Okay. Also, you can calculate easily, but this is better to remember. So we have discussed up to Cn axis. Now another axis has remained, that is Sn axis. Sn axis. For this also use the same concepts, that is here for Sn, any Sn value, any nh, any value, that is you can use same things, cos theta, sin theta 0, this is minus sin theta, this is cos theta, this is 0, 0, 0, this is minus 1. Okay, so here also that trace or characters will be in a second axis. What the value that you will dot the diagonals, diagonal values, so that is cos theta plus cos theta minus 1, that is going to give 2 cos theta minus 1 in Sn axis. Let's say if you take that n equal to, let's say 2, then S2 character will be 2 cos theta will be 180 degree, because this is C2 into sigma h. Okay, so axis will be C2, so 180 degree minus 1. So this is going to give that 2 cos 180 degree is minus 1, and this is minus 1, so this is minus 2 minus 1, that is going to give minus 3. Okay, this is going to be minus 1, 2 minus 1 minus 2 minus 1 minus 3. Similarly, if n equal to 3, then 2 cos theta minus 1, so this will going to give 360 upon 3, that is equal to 120. So again use the same, 2 cos 120 minus 1. So again you use that, here all positive, here after school to college, here sin positive, here tan positive, here cos positive. So here cos 120, so here if I do cos 120, that is negative, so first thing is that it will come negative, so this will come negative, and this cos 1, I can write cos 90 upon 30 minus 1. So this equal to 2 cos, that is sin 30 minus 1. So this sin 30 is 1 upon 2, but this is negative, so 2 into minus 1 upon 2 minus 1. So this rise to give minus 1, this is minus 1, that will give minus 2. Okay, so characters of S3 is that minus 2. Okay, so likewise we will calculate the characters, and we have to remember that the same things as Cn axis, same thing we used, but for Cn axis, that is cos theta sin theta 0, sorry 0, and this will be minus sin theta, this is cos theta, and this is 0 0 here, that will 1, but here minus 1, that is only the difference. Okay, so cos sin 0, after that minus sin cos 0, and this is the character value. This is important for us. Okay, so cos 2 cos plus 1 for Cn characters, that is 2 cos theta plus 1, and here that character 2 cos theta minus 1. Okay, so these are the some things we have to know that before we do the character tables, that characters we should know how to calculate it. So today up to this, thank you.